So in this question they are saying that in YDSE with capital D equal to 1 meter, small d equal to 1 millimeter, light of wavelength 500 nanometer is incident at an angle of 0.5 second degree with respect to the axis of symmetry of the experimental setup. If center of symmetry of screen is at O as shown, so this is center of symmetry. Find the position of central maxima, intensity at point O in terms of intensity of central maxima I naught, number of maxima lying between O and central maxima, and then fourth is if a slab of refractive index mu equal to 3 by 2 is introduced in front of S1 such that central maxima is shifted to point O. Find the thickness of the slab required. So let us try to solve this question. So before solving this question, I just want to tell you that if there are two light rays, as you can see here, there are two light rays 1 and 2, correct? So if these two light rays are meeting at O, so this point is, I have kept this point is O. So if they are meeting at O, then there will be some path difference. So what will be that path difference? That path difference, if this is theta, this angle will be theta naught. This angle will be theta naught. So path difference will be d sine theta naught, correct? So this is the path difference. Okay. Now I am assuming that they are meeting at some point O dash where it is forming central maxima. Definitely at O it will not form central maxima because there is some path difference. So if I consider it is forming central maxima at a distance of y below. So now here at this point central maxima path difference has to be 0. So for path difference 0, what is the path difference between 1 and 2? You can see that this light ray 2 travels extra path of d sine theta naught. Now if this O makes an angle of theta, this angle is given theta. So if this angle is given theta, then I can say that the extra path travelled by ray 1 when it is coming out of the slit is d sine theta, which is I have shown here, you can see. So this is the extra path travelled by ray 1, so that is d sine theta. So what is the total path difference? Delta x can be written as d sine theta naught extra path by 2 minus d sine theta, that is extra path by light ray 1. So net path difference for central maxima has to be 0. So d sine theta naught minus d sine theta equal to 0. So I can say that theta naught equal to theta, correct? Now what I can say, that this I have to find this y, correct? So can I write tan theta equal to y by capital D, where capital D is the distance between slit and the screen, correct? So I can write tan theta equal to theta. So theta, or I can write y equal to d tan theta, but it is below, so I'll write minus of d tan theta. Okay, so this is minus d tan theta. Now tan theta can be written as, that is equal to minus d tan theta can be written as theta, which is equal to theta naught. So minus d theta naught. D is how much? D is 1 meter. What is theta naught? 0.57 degree. I have to convert this into radian. Pi by 180. So pi by 180, you know, 57. So 0.57 divided by 57. So from here I am getting y equal to minus, okay, this is minus 1 centimeter. So this is the distance of central maxima, shifted central maxima from point O. So our first question, this is the answer of the first question. Second question, what they told? Second question, they are telling that intensity at O in terms of intensity of central maxima I naught. Intensity at this point O. So let us try to find what is the path difference at point O. If I can find path difference or phase difference using formula for intensity, I can find, correct? So let us find what is the path difference at O. So at point O, what I can write, delta x equal to what? At point O, delta x will be d sine theta naught, correct? You see the previous diagram. At point O, the path difference will be d sine theta naught. So path difference is d sine theta naught, which is equal to, d is 1 millimeter, d is given as 1 millimeter, so that is 10 to the power minus 3 into sine theta naught can be written as theta naught, that is 10 to the power minus 3 into 0.57 divided by 57, because I have to convert this into radian as previously I have converted. So I will get 10 to the power minus 5 meter. So can I write 10 to the power minus 9 into 10 to the power 4? So I will get 10 to the power 4 nanometer, this path difference delta x. Okay, so what is lambda? Lambda they have given 500 nanometer. Lambda is 500 nanometer. So when lambda is 500 nanometer, n lambda equal to 10 to the power 4 nanometer. Okay, so from here n lambda is how much? 500 into 10 to the power minus 9, that is equal to 10 to the power 4 into 10 to the power minus 9. So n I am getting 10,000 divided by 500. So if I calculate, I'll get 20. So at O, I can say that it forms, at O it forms 20th maxima. 20th maxima. Okay, so what is the intensity of maxima at O dash? Intensity at central maxima is I naught. So at O intensity will be I naught, correct? So this is the answer of the second question. Let us solve third question. So third question they told, number of maxima lying between O and central maxima. So if at O it is 20th maxima, so number of maxima between O and central maxima will be 19 maxima. 19 maxima between O and central maxima. Okay, excluding this O and central maxima. Fourth question they told that a glass slab of refractive index mu equal to 3 by 2 is introduced in front of S1 such that central maxima is shifted to point O. So central maxima shifted to point O. Find the thickness of slab required. Correct. So you can see this diagram. Small d is 1 millimeter, capital D is 1 meter, and if I introduce a glass slab of thickness T, mu they have given 3 by 2. They are asking the central maxima is shifted to O. What is the thickness? What is the thickness of this glass slab? So definitely I can say that the path difference between 1 and 2 in this case should be 0. Now how much extra path travelled by 2, that is d sine theta naught. So how much extra travel light ray 1 has to travel because of this glass slab, that should also be equal to d sine theta naught, correct? So let us try to find delta x at O. Delta x at O will be what? Delta x equal to path difference will be d sine theta naught plus S2O, this is the path traveled by 2, minus path traveled by 1 is S1O dash. Okay, because it's going through the glass slab, so I am taking S1O dash. So that is d sine theta naught plus S2O minus, what is S1O dash? S1O minus T into mu minus 1. So this is extra path traveled because of this glass slab, okay, optical path. Okay, now this is equal to how much? I am getting d sine theta naught minus d sine theta naught minus t into mu minus 1. So obviously, as I told, both the path difference has to be equal. That should be equal to 0 for central maxima, correct? And I know S2O minus S1O is already 0, okay, because both are of same length, okay. So t equal to d sine theta naught divided by mu minus 1. So from here, if I put the value of d, 10 to the power minus 3 into theta naught is 0.57 by 57 divided by 3 by 2 minus 1. So I'll get 10 to the power minus 3 into 10 to the power minus 2 divided by 1 by 2. So from here I get 2 into 10 to the power minus 5. I can also write this 0.2 into 10 to the power minus 6. So the answer is 0.2 micrometer. So this is the thickness of the glass slab required. Okay, I hope you understood this problem. Thank you.